Hi, I'm Kim from NESSP, and in this video, we will explore Lesson 3, Modeling Moving Carbon. This lesson is in Unit 2, Understanding the Earth and Venus, and again, it's Lesson 3 in this year's Roads from Earth to Venus companion course. The guiding question for this lesson is, what is carbon and how does it move and change on Earth and Venus? Next, we'll go over the 5 E's for this lesson. All right, the 5 E's start out with engage. In this part of the lesson, students will organize a card set to tell a carbon-related story. Before the lesson, if you want the students to do the card sort physically with the physical copies of the cards, you'll need to print out one set of the cards for each student, pair, or group, depending on how you want them to work. There's also an electronic version of the card sort if you prefer to have students use the card sort in that way. And you can see here what the card images are. We've highlighted curiosity and gathering prior knowledge as opportunities in this part of the lesson. As students work with the card sort, you will be able to see and hear what they are doing and kind of understand what they already think or know about carbon moving in this way. And you may hear them asking questions. So be alert to that in the lesson plan. After students sort the cards, we move on to the explore part of the lesson. This is the largest part of the lesson. Students will engage with two models of carbon moving and changing, one at the macro level and one at the micro level. There are additional videos to support these models, one for the macro and one for the micro. So if you have any questions about this, consult the lesson plan and the videos which are linked there in the lesson plan. Before the lesson plan, make sure you have understood the teacher notes and preparation for both models. There may be some printing involved. You might need some materials like dice and things like that. Both require decisions about whether you'll engage with the models physically or electronically, and some preparation of materials. In the carbon cycle game, this is printed cards, dice, and handouts. And in the fructose model, it's again printed cards with some baggies and bingo chips. Otherwise, you'll be using those electronic versions. In Explain, students relate both of the models that they did in Explore to kind of compare and contrast them, and then they will create their new model of the carbon cycle in their local area. For younger students, we have the option of them creating a new carbon storytelling card set that is recommended for students in grades 3 to 5, or any age of student can do the local carbon cycle model. What we're looking for here is for students to represent only the parts of the carbon cycle that occur where they are. So, for example, if you don't live near an ocean, don't put the ocean on your local carbon cycle model. Just put the things that students might experience in your local area. It helps students to look at their local area in a new way and to make those local and cultural connections. Next, in the Elaborate section, students will conduct research about Venus in order to create a Venus version of the carbon cycle game. That was the macro model that was explored earlier. Now we want them to think about what the carbon cycle might look like on Venus. There are some resources in the lesson plan, articles, videos, things like that to help support their understanding of what carbon does on Venus, and then they will make their own carbon cycle game. In Evaluate, students will document their work in this lesson and meet the deliverables outlined for MO3. So there are two deliverables for this mission objective, and that is the local carbon cycle model that they make and explain, and the Venus carbon cycle game and explanation that they make in the Elaborate section. And of course, for those elementary age students, we do have that option for them to create the carbon story card set instead of the local carbon cycle model. That's up to you. In Extend, students have the option to investigate NASA careers related to this lesson, and that will come back around in lesson 7, where they work on the career lesson for the entire set of companion course lessons. A few standards alignment highlights for this lesson. From the Next Generation Science Standards, this lesson very much relies on the developing and using models practice. This is one of the 8 science and engineering practices. There are several models used throughout this lesson plan. The storytelling card sort is one type of a model. The carbon cycle game is a simulation, another type of model. The fructose model is a 3D physical model of a molecule. The local carbon cycle model will be a diagram that is showing their local carbon cycle. And the Venus carbon cycle game is another simulation. This entire lesson really focuses on this practice. So if you're not familiar with that, you might want to check it out, and we'll provide those links in the lesson as well. Here's an example of a high school bullet point for this science and engineering practice. This is definitely what this lesson is all about. Develop, revise, or use a model based on evidence to illustrate or predict relationships between systems or components of a system. So that is what we're doing here in this lesson. It's all about modeling, using models, and creating new ones. Some content standards are all through the grade levels, but we just chose to highlight some high school examples here. For HSLS1-5 and HSLS2-5, you see here how we're talking about photosynthesis. The model that demonstrates photosynthesis is, of course, that fructose model, and then developing a model to show the role of photosynthesis in how carbon cycles. So that would be that macro model. These are some of the standards that this lesson aligns to, and there are additional examples in grades 3 through 5 and middle school that are linked in the lesson plan. Time estimates for this lesson. This lesson is a big one. It's going to be very difficult to expedite it unless your students have significant prior knowledge of the carbon cycle. If that's the case, you might be able to combine some of the carbon cycle game instead of doing it twice, only do it once, or switch partway through. You'll check that out when you do the model, but really in this lesson, because there is so much foundational scientific knowledge, your ability to go faster will depend on how much prior knowledge your students have in this area. Otherwise, this is not the lesson to save time on. All right, I hope that helps you understand a little bit about lesson 3. For more information, you can go to our website, nessp.org, and check out all of the resources linked in lesson 3. Good luck with this lesson.